Hello guys. Perev, namaste. Ayok, ni hao, tumilang, sanbonane, huyamor, akwaba, ndiepi, bonjour. Anyway, we have a Lenovo. As always, we do most of these machines, Lenovo, HP, whatsoever. But here we have what? We have a Lenovo. It's turning on, if I'm not mistaken, but there's nothing on the screen. Anyway, let's connect everything. This is one of the hardest jobs, a case when you have what do you call this? You have a machine which is turning on, but nothing on the screen. I always say it's one of my hardest task, dealing with a machine that is turning on but not display. I won't lie to you guys, it's one of my hardest jobs. I hate that party where I'm faced with a machine that is turning on but nothing on the screen. Let's see. But first, in a case like that, let's say you have a machine that is turning on but nothing on the screen. You have to observe how many amps the machine is withdrawing from where? From the power supply, from a DC bench power supply. It's so important to take that measurement, to take note of that measurement, see how many amps your machine is taking. Because for instance, if the machine is turning on and then maybe takes 5 amps, obvious that machine is on, but you won't have anything on the screen, meaning it's not putting up obvious. In a case where you have a machine again and then it's take 10 milliamps, still 10 milliamps is so small for a machine to display. That would probably mean the machine is not fully on, partially on, meaning some power supplies are not working, or if they are not working, if they are working but the CPU it hasn't started, because I think that take more amps on the machine, it's a CPU. CPU is the one which takes more amps, more amperage, more power, more current on the machine. It's the CPU. Anyway, let's do it. Here we do our best, so we'll do our best even now. As always, you do what? You do a physical inspection. I don't see anything suspicious. Okay, I don't see anything suspicious. Let's see what exactly are we dealing with. Let's see if we have a fan spin, we have a light. Let's just see. Okay, wait. First, we have to set a power DC bench power supply to 20 volts. All right, the power supply has been set to 20 volts. Okay, the machine is turning on. It's taking 39 amps. This is strange. Okay, let's switch it off. Okay, I can't believe this. It turns off and then quickly turns on. The machine wants to be on by force. I can't believe this, guys. Okay, let's go deep today. I like us to go deep. Yeah, this to do a video where we separate boys from men. Let's go ahead. Even if we fail to do this repair, but listen to me, you will learn some serious things. Let's go ahead. First, we have to look for a schematic. There's my hard drive for repairs, schematics. There we go. You type. Okay, fine. I have to find an onboard keyboard settings. Okay, accessibility. All right, keyboard, on screen keyboard on. Okay, so now once you are here in your hard drive that has all the type of schematics, you type nm dash a 1.36 2. Okay, there we go. I have the schematic. The cancel. Okay, since we have the schematic, let's go back on the motherboard. Okay, guys, something's getting hot here, and it's getting extremely hot around this area here. Hot. I think it's on the other side of the board. This sensor place here. Let's flip the board. Hi boo, the RAM. Hi boo, can't believe this. The RAM getting extremely hot. Hi boo. The RAM was getting extremely hot. How's that possible? Let's turn on the machine again, because it seems like we haven't found the problem. I believe that RAM was faulty. Let's try now without the RAM. Oh, let's use another RAM. It won't be fair not to use a RAM. Okay, guys, I've connected a RAM, another RAM. Let's see. Okay, the machine is taking 3 amps now. It's no longer taking any voltages, only 3 amps. I mean, it's no longer taking any power except 3 amps. Okay, meaning now it's partially on. It's on, but no power supply. Planes of the power supplies are not on. Let's see what exactly is going on. Make sure you put your multimeter into a range of 20 volts. Turn on. One probe to ground. I normally prefer positive probe to ground. Now let's check everything. The machine, we have a light on the other side that says it's on. No matter what you do, it doesn't turn on. It's on, but it's only take 3 amps, and I don't understand why. Let's start on the RAM. 1.36 is on. Imagine the RAM power supply is on. This should be on only when the machine is told to turn on, but the machine just turn on itself automatically. See, 1.36 on the RAM itself, it's on. The RAM power supply is on. Okay, 19 volts, 1.36 is on. What about the BIOS pin number 8, pin number 7, 6? Okay, 7, 6. Highball, everything's on here. 3.3. What about the 5 volts? What about the 5 volts after pressing the power button? It's also on. What about the 3.3 volts always? What about the 3.3 after pressing the power button? It's also on. What exactly is going on here? What about the CPU? CPU is off. That's why the machine is taking 3 milliamps, because the CPU, it's not on, it's not told to turn on. The CPU is not on. What about 1.05? 1.05, it's also on. Guys, everything here it's on, but the machine is not taking any power except 3 amps. 3 amps. Imagine 3. No, not 3 amps. 3 milliamps. I'm really sorry, guys. 3 milliamps. It's like it's taking nothing, literally nothing. 3 milliamps. Okay, 5 volts. Okay, 3.3 is on. What about 5 volts? 5 volts is also on. Hey guys, the CPU is the only thing which is not turning on. CPU is not turning on. The only thing that is not turning on. What about the SMC? I believe the SMC is on, because if all the power supplies are on, the SMC should be on as well. Okay guys, the machine is turning on, but it's only taking 3 milliamps. It's not turning on at all. It's turning itself on, and all the power supplies are on, but nothing on the screen is not putting up proper. The CPU power is missing. Let's see why. Change your meter to continuity mode. Let's check for short on the CPU. CPU is fine. Check the CPU controller. Okay, I don't think that's a short. Okay, you know what? This is beyond my control. Let's check here. Okay guys, this is gonna be a serious job, and I can't blame the BIOS. I can't say the issue is coming from the BIOS. I think this is our issue. The startup chip is our issue. I have the same motherboard here, of which I don't understand the issue with it. Let's diagnose this one. If not, we'll swipe. We'll take this and then put it into this one. So let's go ahead. Let's start. Let's check the power button out. Take the DC in check. Remove the fan. Remove the RAM. Let's check this. Remove that. Let's put this. Okay, let's continue. Anyway, okay, now guys, we have to connect a DC in jack. DC in jack has been connected. Now let's see the issue with this one. This is turning on. You can see the light. It's taking 22, 35, 36, 37, 35, 34, 37, 35. Let's turn it off. Okay, it's off. This one can turn off, turn on. This one, the CPU is turning on. This one, the CPU is turning on, unlike the other one. So what we can do here, we have the same, these are exactly the same identical boards, but doing finite behaviors. With this one, let's check all the power supplies from this one. Okay, it's turned on by itself. I don't know who told this machine to turn on, but it's fine. Let's check the power supplies. Okay, this one I can see it's missing the 5 volts, the 5 volts MOSFET here. This MOSFET, the one that controls the 5 volts. Maybe let's check why is it. Are they short maybe or something? Okay, no short. Okay, even the one controlling the 3.3 is also missing, because since we have the identical ports, you can see as well, you can see, let's put this in the same shape. There's a MOSFET here next to a BIOS, but here that MOSFET is missing. You can only see the pads, and then again here there's a MOSFET, but here it's missing. Let's put those MOSFETs in. I got the donor board. Let's remove the parts from the donor board. I believe those are N channel MOSFETs, so you'll have to use an N channel MOSFET to replace them. Out and then out. Let's take the donor port away. Now let's put a little bit of flux there. This port is beyond repairs. This one, okay, it is in. Now let's wait for the motherboard to cool down, and let's clean the entire place with alcohol. See. Now let's see. Okay guys, let's see if there will be any change. Let's try with a string. Try with a string. Okay, let's put this thing close. Okay, turn the machine on. It's turning on, but it's taking 200 milliamps. Now it's taking 300 milliamps. Obvious, there will be no display. I think this machine needs 1 amp or something. Okay, let's check for voltage. Let's see. Okay, the CPU is getting hot. Okay, we do have 5 volts. What about the other side? The other side we have 0.9 volts. What about this one? 1.8. What about the other side? 3.3. Okay, something's wrong. Something's wrong. Okay, we should have 5 volts and 5 volts as you saw on the other port, right? But here it's funny because we have 5 and 0.98, but here it's you saw guys what is going on here. Anyway, let's check the chip controlling Q24 and Q23. Okay, so what you do here, you search for Q24. Did I close the on-screen keyboard? Yeah, I did. Okay, let's go on settings again and look for on-screen keyboard. I'm enjoying Windows 11. It's nice, guys. Okay, on-screen keyboard. There we go. Q24. Enter. Okay, enter again. Next, next, next. Where's Q24? Oh, there. Okay, this is a Q24 which controls 3 volts always and 3 volts after pressing the power button. Yes, and the other one, Q25, is for 5 volts. Is 5 volts always and 5 volts after pressing the power button. VS. So now let's check who's controlling this gate, because I feel like there's a problem with the guy controlling the gates. Let's look for Q27 and Q28. Let's go back and look for those Q27 and Q28, because something is not right there. Who's controlling Q27? Those MOSFETs, Q27 and Q28. Something is not right. Oh wait, no, it can't be those MOSFETs. This is controlled somewhere else. So what you can do, copy and then paste and then search. Okay, it doesn't want to show me. Let me just highlight this, copy, paste, next. Okay. Okay, this is critical. So what we can do, okay, we have to look for all of these resistors here, and see if this voltage divider is working fine. Yo, let's gonna be serious. This is gonna be serious, eh? Okay, let's go back. Let's see. Okay, guys, on the schematic on the real board, I can't find those MOSFETs Q something and Q something. But what I can do is, I'm thinking of let's just go back now. I'm thinking of jumping. Let's see. Let's try. there's nothing on the screen. Yes, I saw something. Oh, there we go. Turning on. There we go. Lenovo. I can see some words. I can see everything. The machine has successfully been repaired. All right. Don't be confused. This was supposed to be what? A donor board, right? Yes. But the main board, this is our main board. This is our main board. Fresh one, right? But anyway, we managed to repair this one with the donor board with some missing components. Yes, after jumping those guys. But again, this thing's wrong. We shouldn't jump those guys. Let's ask ourselves why those guys are not allowing power to jump. Two of them, the 3.3 doesn't allow 3.3 to jump, and the 5 volts doesn't allow the 5 volts to jump. I forced them to jump the power, and now the machine is turning on. We have a display. Why, guys? Why?
They can comment down. You can comment, tell us down there. What is the issue? You can comment, guys. Comment down below. Then you can tell us what is the issue here. Why we jump those?
Okay, yes, guys, please feel free to comment and tell us why we jumped those, and again tell us the solution, the permanent solutions, permanent solution not to jump those MOSFETs, because now it means this machine. But again, I was so happy because when I turned it on this time, it didn't turn on by itself. You saw, right? I had to press the power button, and the machine eventually it's turned on after pressing what? The power button, of which is fine. I was so happy with that. Anyway, I'm gonna stop this video and continue on part 2 with the other video, with the main board. Anyway, I love you so much, guys. Bye bye.